Lesson 7.1 is going to introduce you guys to the idea of exponential growth functions. You probably have seen a little bit of this before, so of course we'll get into it a little bit more. Things that grow exponentially, population of the world, cancer cells, bacteria, mosquitoes. Mathematically, what we think about with exponential growth, let me show you two quick things to compare. I can take, let's say, 2, and I can add 2, and I get a 4. If I add 2 again, we get a 6. If I add 2 again, we get 8. That's a constant growth. We're just increasing by 2 each time. Now, where that's not exponential growth, what I just showed you, where if you're just adding a constant number each time. Exponential growth is going to use the idea of multiplication. Let's say we take 2 and we multiply it by 2. We get a 4. And then we multiply that by 2 and we get an 8. Multiply that by 2 and we get a 16. So you can see that we are quickly getting much bigger than if you just add a 2 each time. So exponential growth, things that grow exponentially, it's where you get big in a hurry. And it happens by multiplying by some constant number. You guys are going to be graphing functions. Exponential functions have this form, y equals a times b raised to the x power. One thing to notice about this is now your x is in an exponent position, and that's how we're going to get that exponential growth. To determine whether or not you have a growth function, you want to look at the a value. If your a is bigger than 0 and your b is greater than 0, then you have a growth function. When they refer to something called a growth factor, that's just the b value. So, for example, maybe you would have y equals 2 times 3 raised to the x power. That's a little sloppy, but you get what I mean. In this example, 2 would be that a value. It's greater than 0, so I know it'll be a growth. Oh, and b is greater than 1, so it's a growth. And then the growth factor is that 3. When we graph these, here's what our graphs will look like right here, just a quick little example. It is just going to be a curve. It's going to grow up like this, and it's going to continue to increase and very quickly. So that's that exponential growth. It gets big in a hurry. I can't remember if we've had the idea of an asymptote yet with any of our graphs. It's a line that the graph approaches more and more closely, but it will never cross your asymptote. We'll see more graphs with asymptotes as we move along in Algebra 2. In this case, the asymptote is going to be this line right here. If you see your graph, it's growing up that way, but on this side, it's just going to get closer and closer to that line, but it's never going to cross it. So if you have to identify the asymptote, in this case, it's a horizontal line, so we would say y equals 0. Here I just want to show you what you're going to have coming your way. It says function without the shifting. These graphs are going to shift. So what you're going to look for in your equation, just a heads up, are any plus or minus numbers in your equation. You can see we have x plus 1. That's one of those. Do you see how the plus 1 is in with the x? And if you have had me before, you'll know that I'll call that the tricky x, which means we're going to shift in the opposite direction. So this graph would be shifted to the left 1, and this minus 2 on the end, that's your vertical shift of down 2. So the graphing that you guys have been doing with the way that these graphs shifts will be exactly the same. You'll just look at what is the original function without the shifting, y equals 2 to the x. You'll get those points, and then you're just going to shift everything to the left 1 and down 2. You'll see some videos showing that, but just a heads up, that's where this is heading as far as your graphing is going. So you guys are going to love the fact that exponential growth models bring in word problems. So we'll get great practice with word problems. Again, I think you guys have seen an exponential growth model before, probably from Algebra 1, so we're going to be reviewing this. When you have a real-life quantity that increases by a fixed percent each year, so for example, maybe something is increasing 5% a year, it can be modeled by this equation right here. That a out front is always going to be the initial amount. R will be the percent written as a decimal. And the thing with written as a decimal, if you have, let's say, 8%, just keep in mind that's a 0.08 and not a 0.8, because that 0.8 would be 80%. That's a common mistake I see. I'm hoping not to see it this year from you guys. You'll see some examples of what this is, exponential growth model, but we have a nice little formula we can follow to figure out, what the real life quantity is after however many years. After we get through our exponential growth, and then 7.2 is exponential decay, we are going to get into finance in this chapter. So here's just your first introduction. We do have a formula for something called compound interest. That's when interest is paid on the initial investment, also called a principal, and on previously earned interest. And it can be modeled by this equation right here. P would be the principal amount deposited. That R is your interest rate written as a decimal again. N represents number of compounds per year. Now, a compound, another way to think about that is how often they calculate the interest. And that'll be easier to explain when we see some examples. But, things that are compounded, let's say quarterly, that would be 4 times a year. That means 4 times a year they are recalculating to see how much interest you've earned at that point. And then also you have T, which is the number of years. So this could be an example where maybe you are putting money into a savings account and you earn interest, and it's compounded monthly. So every month they recalculate the interest that you have earned, and they put that into your account. So again, we're going to see more of these finance formulas. That's just the first nice little one we get to look at. And there's just a quick overview of 7.1. You have a handful of videos to watch after this just to see more detail on what I just went over. Have fun.